Now we're going to look at how we can compute binomial probabilities using the calculator. So if we want exactly 4 owning at least 1, what we have to pay attention to is that phrasing exactly 4. That's what tells us what we're looking at. And for this, we have to go into our distributions menu, which is where we're going to be spending a lot of time for the rest of the semester, so it's really good to get used to where that is now. You hit second, and then on vars, right above that, you see in blue DISTR. That means when we're in the second menu, we're going into the distributions. And from here, we're going to scroll down, or up, as you'll see later, until we get to option A, which is binomial PDF. So we use PDFs when we want to find probabilities associated to specific single values. Think point for PDF. And sometimes you'll hear the phrasing for this be point distribution or point density function if you go further with this stuff. But anyway, here we want exactly 4, so we hit PDF. Then our number of trials is the number of households randomly selected, n equals 10. P is the probability of at least 1 dog, 0.365. And here, x is 4 because we want to see if exactly 4 own at least 1. Where you plug all those numbers in, run the computation, and you get a probability of about 24%. If you want to get at most 4, then what you do is you go back to the distributions, and now you pick CDF. So the CDF computation in the calculator, think cumulative. When you're looking at this sort of thing, you're talking about accumulating values up to a point. This is what it's designed to do, where, because we want at most 4, we still have 10 trials, a probability of success of 0.365, and an x value here of 4. So it looks like we're entering the exact same thing, and we kind of are, but we're putting it into the CDF function instead of PDF. And then we make that run. And doing so, we get a probability of about 72%. Now for the last case, we have to do something a bit more subtle, because the calculator here is designed to handle up to. That's what CDFs are built to be good for. Here, we have to be a little careful because we want at least. That means we want 4 or 5 or 6 or 7 or 8 or 9 or 10. And yeah, you can do that by hand, or if you want to use a CDF, what you'll need to do is do 1 minus, and then go in to your distributions, and we scroll up to get to CDF because it's closer to the bottom. And here we still have 10 trials. Our probability of success is 0.365, but now we're going to put in an x value of 3. And once it gets back to the computation, it'll make more sense why I did that. Because what happens here is we're using a complement. If you want to get 4 or more, the opposite of that is less than 4. Or in this case, since it's discrete, 3 or fewer. So if we do it this way, we'll get the desired probability. As we can see, scrolling through these menus, for the point, for the direct accumulation, and then for the complement accumulation. This is how you handle any computation of this manner using binomial CDF and binomial PDF in the calculator.